Okay, intersecting lines. So we can use altitudes and medians of a triangle to solve problems, finding the point of intersection using simultaneous equations. So in this example, F, G, and H are the points 1, 0, -4, 3, and 0, -1 respectively on the triangle FGH. FJ is a median of triangle FGH, and HR is an altitude of triangle FGH, and we want to find the coordinates of the point of intersection D of FJ and HR. Now, step 1, we need to work out the median of triangle FGH. So you can see if we follow the steps. Step 1, work out what the midpoint J is. So we're going to add -4 plus 0 divided by 2 and 3 plus -1 divided by 2, and that gives us the point J, -2, 1, which is the median of GH. Then we're going to work out the gradient of FJ. So 1 take away 0 and -2 take away 1, and that gives us -1/3. So A is 1, B is 0 from point F, and M equals -1/3, and we're going to substitute that into our equation of a straight line. So y minus 0 equals -1/3 upon x minus 1, and if we expand our brackets, and then because we know that we're working out a point of intersection, we're going to put it into the format of a simultaneous equation, 3y plus x equals 1. Right, next up, the altitude of HR. So we need to work out the gradient of GF. So you can see here, we've got 3 take away 0 over -4 take away 1 equals -3/5. We then know that MGF and MHR are going to equal -1. So MHR is going to be the reciprocal, 5/3, and then change the sign, so it's going to be positive. And then we need to substitute that into our y minus b equals m upon x minus a. We're going to use point H because we don't know what point R is. So our a is 0 and our b is -1. So we've got y plus 1 equals 5/3 of x minus 0. Don't like fractions? Let's multiply it out. And so we end up with 3y plus 3 equals 5x. And again, we're doing simultaneous equations. So we want to have our two variables on the left-hand side and our number on the right-hand side. So rearranging it, we get 3y minus 5x equals -3. And that's our second equation. So the final step is to find the point of intersection. So you can see here, we've got our two simultaneous equations for our lines FJ and HR. If we then take 1 and subtract 2 from it, because we've got 3 y's in both of our equations, we end up with 6x equals 4. So x is going to be 4 divided by 6, and we can simplify that down to 2/3. And then we're going to substitute it into either of the equations. I've substituted it into equation 1. So 3y plus 2/3 equals 1. We take away 2/3 from both sides, we get 3y equals 1/3. And if we divide both sides by 3, we get y equals 1/9. And so D, the coordinate of the point where those two lines FJ and HR intersect, is 2/3, 1/9. So exercise 1.9 will give you a chance to practice intersecting lines. Any problems, just ask. I'm more than happy to help.